Go ahead and stand up if you need to stretch. We've been sitting for a bit, so feel free to stand up, stretch a bit if you need it. If you don't, stay seated. It's going to be a little bit. All right, so I want to share a secret with you today. I'm going to talk about how to create a really good fake ID. Something everyone's wanted to know how to do, right? In fact, I don't want to share this lightly. So if you are a college student that's looking for beer this weekend, just raise your hand. Or criminals, if there are any criminals in the room. Criminals in the room, please raise your hand. No criminals in the room. Okay, good. I feel safe sharing this with you. We're in a safe space. My name is Manu Sporny. I'm the CEO of a company called Digital Bazaar. And we help organizations protect against fraud, identity document fraud, things of that nature. And one of the newest types of fraud that we're really concerned about is artificial intelligence-powered fraud. So using generative AI to create fraudulent documents. Now, on the next slide, I'm going to show you what one of these things looks like. And I want you to look very closely at it. Try to see where the AI got it wrong. See if they made any mistakes. All right, so here it is. This is the state of the art. If you look at this image and you look at the person, that person's not real, of course. None of the information on the card's real. The microprinting that you're seeing on the card, not real. In fact, the card itself isn't real, nor is the carpet that the card's sitting on. This entire thing was generated through the imagination of an artificial intelligence. That's what state-of-the-art looks like. Where do you get these things? Where do you get these types of documents today? Video's not playing. Yeah, that's unfortunate. So the way you get these types of documents today is through websites, particularly ones that are available on the open internet. There are sites called onlyfakes.com, and they allow you to put any information. Oh, there we go. Thank you. Here's the video, the OnlyFakes website. They allow you to create any kind of card that you want. European identity cards, US driver's licenses, passports. You can use them and put your own information into them. You can generate whatever synthetic identity you want. None of these people are real that are being generated and put on the card. You can do tens of thousands of these at less than $1 a pop. Those are the real price points. So here's the bad news. These are really easy to generate today. Now, the good news is that we've got something that AI can't fake. We've got cryptography, we've got digital signatures. And if we take these digital signatures and we encode them into barcodes and put them on these licenses, our physical IDs, we can protect them against fraud. We can know whether or not that physical document is real or not. We can protect information on it, like the person's name, license number, date of birth, street address, all the things that you would expect to be safely protected on the card. And we can do this using open standards. This is patent and royalty-free technology. Anyone can implement it, use it. We use W3C verifiable credentials to do this. So there are a number of benefits of doing it this way. One of them is that it's really easy to verify this. What I'm showing you doesn't require advanced hardware. In fact, you just need a mobile phone. So you literally take the ID out, you point your mobile phone on it, and you know whether or not it's a fake ID or not. You can't do that with driver's licenses today. The other thing that's really nice about the technology is it's simple to deploy. So we've been working with states and organizations to integrate this into their current printing processes. We're literally asking you to use the same kind of barcode that you've been using, but modify it slightly. And so it drops in really easily into existing card printing processes. Finally, it works on mobile. It's digital native. You can use the same technology to protect the physical card as you do the digital document. And we're deploying it. In fact, we've deployed it last year. Last year, we deployed it into production through a program called the True Age program, deployed to 150,000 stores across the United States. We are working with U.S. Citizenship and Immigration Services to upgrade the permanent resident card, naturalization certificates, employment authorization documents, and we're helping the state of California deploy this for all 27 million people in the state that have physical driver's licenses. So artificial intelligence is here. Generative AI is now the most powerful tool for committing fraud in history. You've seen it today. But the good news here is we've got something that AI can't fake. And this technology is deployable today at scale. And with that, we'll take questions, if there are any.
There's been a lot of talk about quantum safe and the future of cryptography in light of quantum computing. Mm-hmm. How do you see the technology being able to adapt to a quantum world?
Yeah, that's a great question. So quantum safe signatures, as some of you might know, are very large. It's very hard to encode this information on a physical card. But that's where the digital stuff comes in. So we have these digital wallets, these new digital wallets where we can put verifiable credentials in those digital wallets. And the size of the signatures that you can put in those digital wallets are much larger. So we have mechanisms that we're already working on post-quantum digital signatures for verifiable credentials. And we think those are going to be there well in advance of the 2035 deadline to transition to those. For physical cards, we also have R&D going on in this space. We believe we've got a number of solutions that we haven't publicly announced yet, but probably will be doing so in the next 2 years. So we can get it down to a physical form factor, a physical card form factor, and it's not a problem for the digital form factor.
So eventually you must have a very wide range of end users. Let's see. Eventually you must have a very wide range of end users. Everything from large government agencies to restaurants, bartenders who verify age, librarians issuing a library card, whatever it might be. What's your consideration for those different end user communities? I would imagine that it would take a lot of different considerations. And also related to that, I wonder what happens when you detect manipulated credential or fake ID, basically. We heard from iProve that they collect data from attacks as well. Is that something that you're interested in?
So we work with a large variety of different industries. So let me talk about the retail sector. So the way the retail sector processes IDs is very differently from the way Customs and Border Protection would do it versus USCIS and whatever. So you have to take the context of the transaction into account. For example, in a retail store, if somebody shows you a fake ID and that clerk looks at it, there's a non-zero chance that the person is going to pull a gun on them if they deny them the sale, right? And so in those cases, we have to find a way of putting the blame onto the cash register. The cash register won't open. It's not reading your card. I don't know why, right? The clerk knows it's a fake ID, but they can't let that on. So there's, a librarian doesn't deal with that kind of thing, right? With a book return, right? So we have to think about who's using them, the use case. There's definitely not a one-size-fits-all solution for this. And so we work with our customers to figure out the best way to deal with situations where you're dealing with a fake. Yeah.
I wish I knew about those websites in high school. But I guess that is an extension of the previous question, which is about context, right? Mm-hmm. Because if I'm not carded when I'm buying beer at 7-Eleven, why should I want to digitize my driver's license or some other forms of ID? Are there immediate use cases where access is granted other than beer at 7-Eleven?
I mean, we went for the most high flow use cases. What do people use their driver's license for mostly in the US? It's buying beer. It's going out to bars, right? That is the most, you use it maybe once every, hopefully, couple of years if you're pulled over, right? So we went for high flow use cases. These things, these digital credentials, they need to be used on a fairly regular basis if the general citizenship is going to accept them and use them. And that means, at least for us, targeting the use cases where you see very regular usage. It is much more important for us to demonstrate that a driver's license is being used to prove age, right? Or really in true age, we had a privacy-preserving verifiable credential. We didn't want to use a driver's license because that's sharing too much information. So we focused on high throughput use cases, right?
Okay, sorry. This is like the real question. I'm sorry about joking about the beer, but so like, can you say something about like, will people be able to track that I've now used my ID to access all of these things, and how do you approach that problem set?
That's a great question. So will people be tracked using this technology? The answer to that question depends on the people that are deploying the technology. I think it is a good thing that everyone involved in the project has a lot of privacy oversight, like ACLU, Electronic Frontier Foundation. They are very much involved in the creation of these global standards, and that is a very good thing. To give you an example, in the True Age program, that program knew that if there was any inkling of people being tracked in that system, that it wouldn't work. The public wouldn't trust it, they wouldn't adopt it, they wouldn't use it. And so they took a very aggressive privacy-forward stance and said, no, absolutely not. We're going to data minimize. We're not going to use a driver's license. We're going to use an age token that says you're over 21, and that's that. All right. So it is possible, but that's why you need very good privacy oversight over all these systems.
Thank you very much, Manu.
Thank you.